video, we're going to continue on with our absolute value work. We're going to do day 2 of section 2.8. A couple of definitions here. Something called a disjunction is a compound statement that uses the word or. And then a conjunction is a compound statement that uses the word and. So we can have disjunctions and conjunctions with inequalities. And so here's one example. This is a conjunction. X minus 5 is less than 2, or negative 2x is less than or equal to negative 10. When this happens, we essentially have two different pieces, and we can solve them separately. So we have, I'm going to add 5 to both sides, so I get x is less than negative 3. Or, and then I'm going to do this one, divide by negative 2. Dividing by negative is going to flip my symbol so that I get x is greater than or equal to 5. Oh, sorry, I should put that on the same line. So I have x is less than negative 3 or x is greater than or equal to 5. So on a number line, what that an or inequality looks like is we're going to have two values, negative 3 and 5. Over the negative 3, we have an open circle because it's just less than. And over the 5, we have a closed circle because it's greater than or equal to. Greater than or equal to 5 is all the values to the right of 5. Less than negative 3 is all the values to the left of 3. So anytime we have an or, that's what this is going to look like. They're going to be going in opposite directions because it's solutions here or here. And it's not possible for a solution to be here and also here. Okay, then the difference is a conjunction. So we have the word and. So we're going to see the difference here when we graph. So I'm going to solve them separately here. So dividing by 1/2 is the same as multiplying by 2. So I'm going to get c is greater than or equal to negative 4. And here I've got to subtract 1. And I have 2c plus 1. Oh, sorry, got rid of the 1. Is less than 0. Divide by 2. So I get c is less than 0. Okay, so here's why this one is an and. C is greater than or equal to negative 4, and c is less than 0. So what that looks like, if I plot this on a number line, negative 4 and 0. Over negative 4, we have a closed circle, 0 open. Well, if it's greater than negative 4, it's going to be to the right, and if it's less than 0, it's going to be to the left. So in here, we actually have our line between the two values. So and is going to give us values in between, or is going to give us values on the outsides. Okay? All right. This is just, again, some kind of review, but with inequalities. So the other video, we talked about absolute value being the distance away from 0. So distance from 0 in this case is 3. Okay? The distance from 0 is less than 3 is what this one means. And then the distance from 0 is greater than 3. So what that looks like on a number line, you guys, is when we have the distance from 0 equals 3, we have two possibilities, right? We have going to the right, so 3 is a solution. So I'm going to put a closed circle there. And then 3 the other direction, right? Negative 3. So those two would be solutions to this absolute value equation. Now for an inequality, we kind of treat it the same thing. We're saying the distance from 0 is less than 3. So it could be less than 3 from the right and less than 3 from the left. So that is where we get an and inequality. So from negative 3 to 3, because 0 up to 3, I'm going to do an open circle because it's not including 3. But everything from here up to 0 is less than a distance of 3. And everything from 0 up to positive 3 is a distance less than 3 from 0. So again, this is the and situation. Okay, here the distance from 0 is greater than 3. So to get something further away from 0 than 3, we have to go on the outsides of 3. So that's going to be an or. So negative 3 out, all these distances are greater than 3 away from 0. And then all these distances to the right are 3 greater than 0. Or, yeah, greater than 3 away from 0. Okay, so there's a couple ways we can solve or an and. We stop above them actually written as or an and right away. So what we're going to see is actually something like this, where we're going to have absolute value of an expression, and then depending on whether it's greater than or less than, we can set up an equation. So I'm going to flip actually back really quick. If it was greater than, we ended up with, sorry, down here at the bottom, if it's greater than, we ended up with an or inequality. So that's exactly what I'm going to do. If it's greater than, it's going to be an or inequality, and if it's less than, it's going to be an and. So I'm going to show you how to do that. Okay, so we are going to set up, sorry, let my camera focus here. There we go. Okay, so I'm going to set up two inequalities with or. Okay, so I'm going to do 5 minus 3x is greater than 9. Okay, so that is just as it is, or, and then again, back to this example. So when it was 3, we had it was greater than 3 or less than negative 3. So it's going to be, or this expression is going to be less than negative 9. So basically we write one as it is. For the or piece, we write the expression the same, but we flip the symbol and make the constant negative. So now I'm just going to solve each of these separately. So I'm going to subtract 5, divide by negative 3. So I got to flip my sign. So I get x is less than negative 4/3. Okay, add 3. So I get 5x is less than negative 6. Divide by 5. So I get x is less than negative 6/5. Okay. Oh, I'm missing my, I did that again, you guys. I'm sorry. I really want to put the x with the 5 for whatever reason. So let's try that again. All right. Okay, let's try that written correctly. Okay, 5 minus 3x. So I got to subtract the 5 first. There we go. Negative 3x is less than, what do we get there? Negative 14. Divide by negative 3. So again, I got to flip my symbol. So I get x is greater than positive 14/3. Okay, so again, we have or. So on the number line, negative 4/3 is smaller than 14/3. So I'm going to put it on the left. So 14/3. Both are just less than or greater than, not less than or equal to, and it's or greater than 14/3, less than negative 4/3. So it's going opposite directions. All right, this one is a less than. So we know, back to our previous page here, less than is an and inequality. So it's got to be greater than the negative value and less than the positive value. So I'm going to show you one way to write this here that's called a compound inequality. So I have whatever this is, it's got to be between the negative value of that and the positive. So I'm going to write it like this. It has to be between, I keep the symbol the same, then the expression, and then the positive. Okay, so this expression is between negative 10 and positive 10, making it that and piece. So it's greater than negative 10 and less than positive 10. Now, this we're going to solve the same way. I'm going to get q by itself, so I'm going to subtract 2. Now, this is kind of interesting because I have 3 pieces here with the compound inequality, so I have to do it to all 3. So I get negative 12 is less than or equal to negative 4q is less than or equal to 8. Now I have to divide by negative 4. Again, I have to do that to all 3 parts, and I am working with an inequality and dividing by negative, so I got to flip my sign. All of them. So I get positive 3 greater than or equal to q, now q is by itself, negative 2. So a way to read this, q is greater than or equal to negative 2 and less than or equal to 3. So negative 2 is smaller, so I'm going to put that on the left. 3 is the larger value. They're both greater than or equal to signs, and then it's and, so it is in between. It's greater than negative 2 and less than 3. Okay, so try this one here. Just like when we were solving absolute value equations, we want to get that absolute value piece by itself first. So I'm going to add 3 to both sides. So I have 0.5r is greater than or equal to 0. Okay, so this is an or because I have greater than. So I'm going to say 0.5r is greater than or equal to 0. And then the or piece is 0.5r is less than or equal to negative 0. But negative 0 isn't really a thing, right? I can think about that as negative 1 times 0, which is still 0. So this says, and again, I can solve these, right? I can divide by 0.5, so I get r is greater than or equal to 0, or r is less than or equal to 0. Well, greater than or equal to 0 or less than or equal to 0, that's everything, right? So 0 included, so closed circle, greater than 0 is this way, less than 0 is this way. So this one, our solutions are actually all real numbers. Okay, there's that in interval notation for you. Okay, a couple more here, guys. Okay, this one, I want to, again, isolate the absolute value expression. So I have to get rid of that negative 3 being multiplied first. So I'm going to divide both sides by negative 3. I have to flip the sign because I just divided by a negative. So absolute value of x plus 1 is less than positive 2. So now it becomes an and equation because it's less than. So I'm going to set up my compound inequality. It's got to be between negative 2 and positive 2, and I just keep the expression in the middle. So to get x by itself, we're going to subtract 1 from all 3 parts. So I get negative 3 is less than x is less than 1. So negative 3 up to 1, open circles, it's greater than negative 3 and less than 1. So our line is in between. Okay. This time we are given the graph and we're trying to write an absolute value inequality. Remember, this is the same kind of thing we did before where I have absolute value of x minus the center. Okay, so center. And then equal d, where d was the distance from center. Okay, but now we're adding in the and the or piece. Okay, so if it's or, it's going opposite. So or is greater than or greater than or equal to, and the arrows go this way. Okay, and is if it's less than or equal to, and the arrows are between. Okay, so if we look at this one, this is an or inequality, so I know it's got to be greater than or equal to. The circles at the points are closed, so that makes it greater than or equal to. So I know I have, I'm going to write it up, we'll write it next to it. So I have absolute value of something is greater than or equal to something. That's about all I have so far. Okay, so the center here between where those points are is 0. So x minus 0 or just x. Okay, so absolute value of x. Okay, now my distance, so that's my c, my distance is how far is it from the center to that value. So it's 4. So that would be absolute value of x is greater than or equal to 4. This one is an and, so I know it's got to be less than, and it's an open circle, so it's not less than or equal to. Okay, the center between 8 and 2 is 5, so c is 5, and then the distance from the center to the outside point is 3. So I have x minus 5 is less than 3. Okay. Last graphing one here, you guys. Center between negative 2 and 10 is negative 6. Okay, so c is negative 6. My distance here is from the center to that point is 4. So we have absolute value of x minus negative 6, which is going to make it x plus 6. It's an or, and open circles, so just greater than, and our distance there is 4. Okay, that is it for those ones. We got one last one we're going to write an inequality for. Okay, you are selling cookies. Your package, you package 53 cookies in each box. The box can be off by no more than 3 cookies. Write an absolute value inequality to model the situation. So in other words, If there are 50 cookies in each box, that's okay. If there are 56 cookies in each box, that's okay, but anything outside of that is not okay. So that means the range is between 50 and 56. So if it's a between situation, it's going to be an and, which we know has to be less than. So absolute value, okay, of this, and it can be 50 and it can be 56, so I'm going to include that and make it less than or equal to. Okay, so if I think about that on the number line, right, my range is between 50 and 56. Okay, so the center is 53, right? That's my center. So it's got to be x minus 53, and the distance away from those is 3. So that's what goes here. So this would be an absolute value inequality to model that scenario. Okay, that's it for 2.8 day 2. Thanks for watching.